Hello everyone, I'm your host Chloe, and I'd like to thank you for joining me for today's episode of Clear Skies. Today we'll be discussing one of the zodiacal constellations, Taurus. This is one of the oldest constellations, dating back to the Copper Age. We'll discuss the stars and clusters that compose this constellation, and then we'll go through the mythology and history surrounding this constellation in various cultures. Thank you so much for joining me. I truly appreciate each and every one of you. Now let's get out our red capes and go fight this bull. Taurus, or the Great Bull, is visible from November through March. This is the second of the 6 constellations that constitute the winter circle, and the first of the 12, or technically 13, zodiacal constellations we will be covering. The zodiacal constellations are defined as those which the sun's apparent path through the sky crosses. This constellation is thought to be the very first zodiacal constellation that the Babylonians identified, and it was shown as the first zodiac in the cycle in several cultures. The various zodiac signs were assigned based on what constellation the sun was in during those dates, but due to the precession of Earth, those dates no longer align. I am considered a Cancer, but the sun was actually in Gemini when I was born. If you'd like to know your new sign, the corrected dates will be posted on the blog post for this episode. Now, there are actually 13 constellations that the sun's path crosses through, and the sun spends a varied amount of time in each constellation due to the differences in size. But to make the dates align better, the Babylonians chose to evenly split the year among 12 constellations rather than 13. This was better, as 360 degrees is evenly divisible by 12, but not by 13. Several years ago, NASA officially added the 13th constellation, Ophiuchus, to the zodiacal constellations. He actually has some pretty cool mythology and traits, but we will fully discuss him in his dedicated episode. Of course, astrology is really fun, but it is certainly not scientific, so let's get back to the astronomy. This constellation is the only one in the sky that is not only crossed by the ecliptic, the sun's path through the sky, but also crossed by both the celestial equator and the galactic equator. It is also crossed by the Gold Belt, an incredible region of star formation, which I think we will devote an entire future episode to. Since this constellation is very close to the celestial equator, it's visible in most of the world, from 90 degrees to about negative 65 degrees, so all but the most southern locations. Now, this is a fairly large constellation, the 17th largest in the sky, and it contains 17 named stars and 2 Messier objects. We've referenced this name Messier before, and later in the episode we'll delve into exactly what that means and where it came from. Now, being such a large constellation, it's fairly easily found. The simplest way is by using the constellation from last episode, Orion. This constellation was also mentioned in most of our mythologies from last episode, as they are often seen as related. Now, if you're able to find the 3 stars of Orion's belt, you can find Taurus. You draw a line going through all 3 of Orion's belt stars, and continue that line upward in the direction that Orion is facing, and you will come to a bright, visibly red star. This star is Aldebaran, or the Eye of the Bull, which we will discuss in depth later in the episode. But as the name suggests, this is where the eye of the bull's face would be. The shape we are looking for is basically a face in profile, outlined by a V shape and an eye, and then horns arching out towards Orion. Now that V shape of stars creates the face. The 2 stars at the very end show the end of the bull's horns. From that bifurcation point is a line of stars, which can form like the back or side of the bull, and then there are 2 stars below this line, which can help form 2 of the bull's legs. I find the face and horns to be easy to see, but the rest takes a lot of imagination. If you would like to see a map of this constellation, you can find that, as well as photographs or drawings of all the nebulae, galaxies, mythical characters, and all of the other fun things we discussed in this episode, by going to our website at clearskieswithchloe.com, which is also linked in the show notes. This constellation has some pretty cool stuff going on. It's a less defined constellation than Orion, but it does have some beautiful and well-known objects. It consists of 19 stars total, 9 of which are known to have exoplanets. there are 2 different star clusters and several Messier objects. Now, the brightest star of this constellation is Aldebaran, often referred to as the red eye of the bull or the eye of Taurus. Its name comes from an Arabic term meaning the follower, derived from a longer phrase meaning the bright one of the follower, as it appears to follow the Pleiades star cluster through the sky. This star is the 14th brightest in our night sky and the brightest star in the zodiacal constellations. It's also fairly close at only 65 light years away. Its red color tells us that this is a relatively cool star, and it must be very large to be so bright. This logic holds as the star is cooler than our own at 3900 Kelvin, and its radius is 44 times larger than our own sun. The star therefore puts out over 400 times the energy, or is 400 times more luminous than our sun. This star rotates very slowly, taking 520 years to rotate fully, which compared to our 24-hour rotation is incredibly slow. This star has a giant exoplanet in its gravitational pull, approximately 14 times the size of Jupiter, and it is known as Aldebaran b. This planet is currently very hot due to the large size of its star. However, it is approximated that this planet was around the same temperature of Earth earlier in Aldebaran's life. It orbits at 1.5 times our distance from the Sun, and it's thought that it was likely habitable billions of years ago. Aldebaran is one of the most studied stars in the sky, and was one of the stars used to prove proper motion. Proper motion is the movement of stars along our line of sight with respect to other stars. This shows that they are moving through space independent of one another. We will discuss proper motion as well as other classic astronomy discoveries in future episodes. Now, due to the amount of research that has been done on this star, and therefore having very good estimations of all of its various properties, it was also used to calibrate the Hubble Space Telescope and to calibrate the stellar parameters used during the Gaia Space Observatory mission. Alright, so let's move on to the second brightest star in the constellation, which is Elnath, or Beta Tauri. This star lies along the border of Taurus and our next constellation, Auriga. Therefore, the star has a second designation, Gamma Auriga, though this one is much less often used. This star forms the northern point of the bull's horns. If you can find the V shape of Taurus's face and extend that V shape further outward, you will come to a bright star on both points. The northern one and brighter one is Elnath. The name of this star loosely translates to the budding, referring to being budded by the bull's horns. This star is about twice as far away as Aldebaran at 165 light years and is very different. It is a small, hot star shining blue-white with a temperature of about 13,600 Kelvin. This star has about 4.5 times the mass of our sun and exudes 700 times the energy. Now, this star marks an interesting part of the sky. This is the closest visible star to the galactic anticenter. The galactic anticenter is not a specific point, but a direction. In a later episode, we will discuss how to find the center of our galaxy, but this is the exact opposite. Just 3 degrees to the east of Elnath, about the width of your thumb at arm's length, is the direction to the closest edge of our galaxy. While Elnath is only 165 light years away, the edge of our galaxy is thousands of light years away, but as you look here, you are looking out towards the outer rim of our home galaxy. If you are somewhere dark enough to see the Milky Way or the edge of our galaxy across the sky, you may notice that this region of the Milky Way is rather dark. This is because this section of sky is also home to the Taurus-Auriga molecular cloud complex. This is also referred to as the Taurus dark clouds, as the sparse filamentary clouds of gas and dust block out the light of the background stars. These clouds are the closest large region of active star formation at only 490 light years away, and they stretch across 98 light years. These clouds hold 35,000 solar masses worth of material. Compared to the more familiar Orion Nebula, this stellar nursery is far less dense. They have less mass, but stretch across a larger expanse. Now, as I mentioned earlier, Taurus has 2 star clusters and several Messier objects within its boundaries. So we're going to start with those 2 star clusters first. Now, most of the stars in the V-shaped asterism are part of what is called the Hyades star cluster. However, Aldebaran, the brightest star, is the only major star that is not part of this. Now, the Hyades are the second closest star cluster to Earth, further only than the Ursa Major moving group we discussed in the first episode, which gives us most of the Big Dipper. These stars making the V-shape of Taurus are the brightest of the cluster's several hundred stars. On a dark night, the naked eye can see about a dozen of them, but with a small telescope or binoculars, several dozen can be seen. This cluster mainly contains red giant stars and white dwarfs, telling us that this is a very old cluster. It's approximated that it's about 600 million years old. Now, several stars in the Hyades were photographed during the solar eclipse of 1919, helping to add evidence to Einstein's general theory of relativity. These stars help to show that light does bend around the sun, in line with Einstein's predictions. Likely the best known object in Taurus is our second star cluster, the Pleiades, also known as Messier 45. This cluster is easily visible with the naked eye and is even the inspiration for the Subaru logo. The Pleiades can be found in the northeast corner of Taurus, along the same line as Orion's belt and Aldebaran, and it constitutes the bull's shoulder. Many people can see 6 or 7 stars with the naked eye, but I can maybe only see 5. But those with exceptional eyesight may see even more. One astronomer mapped out 11 of the Pleiades stars prior to the invention of the telescope. It's said in the past that this cluster was used as an eye test by Native Americans and other cultures. It was used to separate out those who would be better suited to hunting or gathering and other tasks. This cluster has had other cultural significance as well, and the name is thought to have come from the Greek to sail, as the appearance of the cluster before dawn marked the opening of the Greek navigational season. It's estimated that this cluster contains 500 to 1,000 stars, each around 100 million years old. This cluster seems to have originated from the same cloud of gas and dust as they continue to move together. Now, the stars in this cluster do vary greatly. It has both many large bright stars and several brown and white dwarfs. It's estimated that this cluster will dissipate in approximately 250 million years, as their individual paths slowly diverge. Now, we've mentioned the Messier catalog numbers in each episode, and they're going to continue to come up, and they're also marked on almost any star map, so I'd like to give you a little bit of background on this. Charles Messier was a French astronomer who began working with the French Navy in 1751, and he kept meticulous records of his celestial observations. In 1757, Messier was searching for the return of a comet predicted by Edmund Halley. Some of you may remember seeing this comet, Halley's Comet, in 1986. Due to a mistake in calculation by Messier's employer, he was searching the wrong part of the sky. He was actually searching in Taurus. Through repeated observations, he saw that the fuzzy patch of sky did not move in relation to the background stars and must not be a comet. This nebula he had just found became the very first object in his now famous catalog and was labeled Messier 1 or M1, and it's now known as the Crab Nebula, which we will discuss in depth in just a moment. From there, he went on to find Messier 2, a nebula in Aquarius, which had been previously discovered by an Italian astronomer. He later found a globular cluster named Messier 3 and became determined to scour the skies and identify all of the fuzzy patches of light. The purpose of his research was to help present and future astronomers to identify which objects are known and constant and which are actually new comets just coming into view. In only 7 months in 1764, he added 38 objects to the catalog. He even recorded 9 new nebulae in one night on March 18th of 1781. As you can probably tell, he went about his project with much fervor and purpose. By 1781, there were 103 nebulae in his catalog, 40 of which had been discovered by Messier himself. 7 known to be discovered by him were added to the catalog in the 1900s, with the most recent, Messier 110, being added in 1967. The catalog does not only have nebulae, but also galaxies, binary stars, and other celestial objects. This catalog still remains a very useful tool, both in referencing and identifying objects to this day. As he was originally searching for comets, it's worth noting that he did discover 13 new comets through the course of his lifetime. But from here on, when we reference M numbers or Messier numbers, just know that these are scientific names for the objects and often how they are listed and can be found in things like automated telescope software and night sky simulators. So now we're going to discuss the very first Messier object, M1, which is also called the Crab Nebula. This is a supernova remnant, close to Zeta Tauri, or the southern horn of the bull. This supernova was visible from Earth on July 4th of 1054. It was even visible during the day and was mentioned in multiple Chinese historical texts. These texts referred to it as a guest star and described it as 6 times as bright as Venus and almost as brilliant as the full moon. This supernova was emitting the light of 400 million suns and was described as having 4 pointed rays and a reddish-white color. It was visible during the daytime for almost a month and in the evening for over a year. It was also seen in North America, as evidenced by paintings in New Mexico's Navajo Canyon and a cave at White Mesa, as well as pieces of pottery depicting the event. While it was incredibly bright, it is now too dim to be seen without a telescope. The nebula was first observed through a telescope by astronomer John Bevis in 1731, who noted the strings of gas and dust that gave it its distinctive shape, which are too faint to be seen by the bare eye, even at its brightest. 27 years later, it was added as the first entry in the Messier catalog. As technology advanced, it was noticed that the nebula was a very strong source of radiation, and astronomers continued to study it, hoping to find the source of this radiation. In 1968, they finally discovered an object at the nebula's center which emits bursts of radio waves 30 times per second. This was among the first discovered pulsars, and is the fastest and most energetic pulsar formed from a supernova explosion that we have found to date. The object at the center was determined to be a neutron star, which was only a theoretical object at the time. Because neutron stars are so dense, having formed from the collapsing giant star, they can withstand the rapid rotational speed they were observing. This pulsar is so powerful, the nebula is more than 75,000 times brighter than our sun, even after all of this time. Now the last one we'll discuss is the Crystal Ball Nebula. And this is a planetary nebula which was discovered by William Herschel in 1790. Prior to this, astronomers believed that nebulae were unresolved groups of stars, but Herschel could discern a star at the center, surrounded by nebulous clouds. In 1864, William Higgins was able to get and use a spectrum of this to show that it is, in fact, a luminous gas cloud rather than multiple stars. For those of you that enjoy a good meteor shower, this constellation offers several. The Taurus shower is in November, and in mid to late October we have the northern and southern Taurids. During June, we even get a daytime meteor shower which is visible via radio astronomy. This constellation is a well-known and popular one, so the nerds among us may have recognized the name Aldebaran from some pop fiction franchises. These references include Lovecraft's The Cthulhu Mythos, Lim's short story collection The Invasion from Aldebaran, Ursula K. Le Guin's novel The Lathe of Heaven, and Douglas Adams' The Hitchhiker's Guide to the Galaxy. It's also been used on TV in multiple episodes of Star Trek, the original series, and one episode of Star Trek, The Next Generation. Now, as I mentioned earlier, this constellation dates back to the Copper and Early Bronze Age. During this time, from about 4000 to 1700 BC, this constellation marked the position of the sun during the spring or vernal equinox. Because of this constellation was of great agricultural and cultural importance. Last episode, we discussed the myths surrounding Orion, many of which included Taurus, as they are often seen as locked in a celestial battle. So for this episode, I have tried to find myths that concern Taurus alone, or alternate versions of ones previously discussed. Fortunately, these constellations are so well known and popular throughout history, this did not present much of a challenge. It seems that for as long as this constellation has been around, it has been widely associated with bull imagery. This was certainly the case back to the Copper Age or even the Late Stone Age, but it seems that it went much further back than even that. The Lascaux caves in France seem to have a painting of Taurus as a bull, clarified further by the presence of the Pleiades. These paintings date back to about 15,000 BC. In ancient Egypt, the bull was associated with the renewal of life and spring. As the sun entered into Taurus, nearing the spring equinox, the constellation would be covered by the sun in the west. This sacrifice led to the renewal of the land and ushered in all of the benefits of spring. Across the Mediterranean Sea in Greece, Taurus is associated with Zeus himself. There are two separate versions of this myth. According to legend, Zeus transformed himself into the form of a magnificent bull with a nice white coat and golden horns in order to catch the attention of the Phoenician princess Europa. Once Europa decided to sit on the back of this bull, Zeus drug her out to sea and took her to the island of Crete, where he revealed his true form and showered her with gifts in order to win her affections. The two became the parents of 3 children, including Minos, the legendary king of Crete. Artwork of this shows only the front part of the bull, which is often attributed to the bull being half submerged as it swam away with Europa. Now, in the second myth, Taurus represents Zeus's mistress Io. Zeus turns her into a bull in order to hide her from his wife Hera. I don't know about you, but Zeus isn't being exactly a great guy in either of these stories. Now, in an unrelated story, one Greek mythographer marks Taurus as the same that formed the Cretan bull, one half of the pair that created the Minotaur. In the previous episode, I had mentioned that Australian Aboriginals may have noticed the variability of the brightest star in Orion, Betelgeuse, many, many years ago. I decided to keep that story for this episode, as most of the stars mentioned are actually in Taurus. So, one traditional story, the Orion story, tells how the constellation of Orion, often portrayed as a male hunter, chases after the 7 sisters of the Pleiades star cluster, located next door in Taurus. Standing between Orion and the Pleiades is the eldest sister, represented by the Hyades star cluster. This eldest sister taunts Orion by standing before him and defending against his advances. The club in Orion's right hand, which is the star Betelgeuse, fills with fire magic, ready to throw at the eldest sister. However, she lifts her foot, which is the star Aldebaran, which is also full of fire magic, and humiliates Orion by putting out his fire. This could easily be referring to his club filling with fire magic during the bright phase, and the eldest sister putting out his fire during the dim phase. Another part of this story discusses sparks coming from Orion when he's filled with lust for the 7 sisters. This lines up with the annual Orionid meteor shower in October, in which we travel through the debris from Halley's Comet. Now we're going to go over a few myths and traditions that associate this constellation with other animals. In Alaska, the Inuit saw the Hyades cluster as representing the spirit of a polar bear, with Aldebaran being the bear itself, and the rest of the stars being dogs keeping the bear at bay. The Druids also held a festival while the sun passed through this constellation. The Druids can be thanked for our modern-day Halloween tradition, as they had a religious rite that coincided with the midnight culmination of the Pleiades cluster. They believed that the veil between the living and the dead was at its thinnest when the Pleiades reached their highest point in the sky at midnight. Now back in the Americas, the Seri people of Mexico saw the Pleiades stars as 7 women giving birth, with Aldebaran giving light to these women. It was also said that long ago, they believed that once a girl could see at least 5 of these stars, she was ready to have a family. Their name for the star translates to the star that goes ahead, and the month of October had a name meaning Aldebaran's path. Another tribe, the Zuni tribe of Mexico, used the Pleiades as an agricultural tool. They referred to the Pleiades clusters as the seed stars. Once these stars disappeared at dusk in the spring, they knew it was safe to plant their seeds as the winter was over. They also knew that they needed to plant prior to the Pleiades reappearing in the eastern sky, as it would then be too close to autumn for their crops to flourish. Well, those are all the stories I have for you today. I truly hope that you've learned something new today and that you enjoyed this episode. If you are enjoying Clear Skies, please leave us a 5-star review on Apple Podcasts, as that is the best way to help us reach new listeners. Please also share this podcast with everyone you know, and make sure you're subscribed so you will get each episode directly to your feed. All of our resources, photographs, and maps are located on this episode's page at clearskieswithchloe.com. That is Clear Skies with CHLOE.com. You can also reach out to me directly on Instagram at Clear Skies with Chloe. I would love to hear your thoughts, suggestions, opinions, questions, anecdotes, anything and everything that you would like to share. We will be doing varied astronomy topics as well, so if there are any topics you'd like us to cover, please definitely let me know. Again, thank you so much for joining me, and wishing you clear skies ahead.